All right, let's dive in. Today, we're talking about how to unlock a new superpower for your code. And this is all inspired by the fantastic book, A Common Sense Guide to Data Structures and Algorithms. Now look, this isn't about some scary high-level math. It's about a fundamental shift in how you think. A shift that lets you write code that's not just functional, but way faster, smarter, and just more elegant. And you know, it's not just me saying this. Scott Hanselman over at Microsoft put it perfectly. He said, gaining this knowledge is like getting a new superpower. And that's exactly what we're aiming for today. That aha moment where you look at code and suddenly a whole new world of possibilities just opens right up.
So let's kick things off with a really important question. You've been coding away, you finally hit run, and it works. That's an amazing feeling, right? But here's the thing. Is it actually efficient? Is it fast? And maybe more importantly, what happens when you throw 1,000,000 items at it instead of just 10? Is it going to stay fast?
This brings us straight into what the book calls the "it works" trap. And trust me, it's a place every single one of us has been, especially early on in our coding journey.
Look, when you're first learning, we've all been there, right? The one and only goal is to make the thing run. Does it spit out the right answer? Yes, awesome, we're done. But focusing only on that one metric can hide this massive problem lurking just beneath the surface. And that problem is performance. At the very heart of all this is the idea of an algorithm. And you hear this word thrown around and it can sound kind of intimidating, but it's not. An algorithm is just a recipe. It's a set of steps for doing something. It's literally the instructions for making a bowl of cereal. And in the exact same way, every piece of code we write is just an algorithm, a recipe that we're giving to the computer. And here's the absolute key takeaway. You can have two different recipes that make the exact same bowl of cereal, but one recipe might take 2 minutes while the other takes an hour. The same is true for code. You can have two algorithms that get the exact same result, but one can be thousands, literally thousands of times faster than the other.
Okay, so how do we even measure this? How can we talk about the speed of our code in a consistent way? Well, for that, we need a kind of speedometer. And that speedometer is called Big O notation. Again, don't let the name throw you off. Just think of Big O as a way to classify our algorithms based on how their runtime grows as the amount of data gets bigger. It's not about measuring in seconds or milliseconds. It's about the rate of growth. And, really importantly, it always focuses on the worst-case scenario, so we always know the absolute slowest our code could possibly be.
So let's compare two really common ones. You have O of n squared, which you often see with nested loops. This one gets very slow very fast. Its runtime just explodes as the data grows. If you double the data, the number of steps can quadruple. Now, compare that to O of n. This one scales linearly. It's predictable. You double the data, it takes about double the time. That's manageable. That O of n squared curve, that's a performance disaster just waiting to happen.
Okay, this is the fun part. Now we're going to see how a simple change in our thinking, powered by choosing the right data structure, can transform a super slow O of n squared algorithm into a lightning-fast O of n1. This, right here, is where you unlock that superpower.
So here's a classic problem. Find the first duplicate number in a list of numbers. Seriously, take a second and just think. How would you solve this? For most people, the first idea that pops into their head leads them straight to the slow solution. So the intuitive way, the first thing that probably comes to mind, is nested loops. You grab the first number, and you loop through the entire rest of the list to see if there's a match. Nothing? Okay, now you grab the second number, and you loop through the whole rest of the list again. You see the problem? For a list with n items, you're doing roughly n comparisons n times. That's n times n, or n squared. Ouch, that's slow.
But what if there was a better way? What if, for each number, we could just ask a simple question? Hey, have I seen you before? And what if we could get the answer to that question instantly, in just a single step?
And that's where our hero comes in, the hash table. It is a data structure designed for exactly this kind of magical lookup. Think of it like a perfect filing cabinet, where you can store and find any item in what's called O of 1, or constant time. That means it takes just one step. One. No matter if you have 10 items or 10 million. It's incredible.
So let's try this again with our new superpower. We create an empty hash table. Then we make just one pass through our list of numbers. For each number, we ask the hash table, have you seen this before? If it says no, we add the number to the table. If it says yes, boom. That's it. You found the duplicate. We only had to look at each number once.
This is an O of n solution. We just went from what could have been millions of steps down to just a few thousand. That is the superpower.
Now, the hash table is just one tool. The real power comes from realizing you have a whole toolbox full of these data structures, and each one is perfectly designed for a specific kind of job.
Choosing the right data structure is exactly like choosing the right tool for a home improvement project. I mean, you wouldn't use a sledgehammer to hang a picture frame, right? Knowing what's in your toolbox lets you pick the perfect tool to make your code efficient and clean every single time.
For instance, let's take a stack. It's what we call a last-in, first-out structure. The book has a great analogy. Think of a stack of dishes. You can only put a new dish on top, and you can only take a dish off the top. And you see this every single day. The undo button in your text editor, that's a stack in action.
Another amazing tool is the graph. It's just a structure of nodes and the connections between them. Think about it. Your social network, that's a graph. A map of flights between airports, that's a graph. Graphs are incredible for modeling relationships, and they power everything from Google Maps finding you the shortest route to Netflix recommending what you should watch next.
So, what's the big picture here? What does this all add up to? Well, it's about much more than just knowing a few new tools. It's about fundamentally changing your mindset.
Look, the goal here isn't to memorize a bunch of weird terms. It's about building an intuition. It's about getting to a point where you can look at a problem and think, this feels like it's all about lookups. A hash table would be perfect. Or, this is all about connections between things. I should probably use a graph. It's about making those educated, common-sense decisions about your code.
And the end result? The payoff? As the book puts it so well, it's that you'll be equipped to write code that isn't just functional, but code that is truly efficient, fast, and elegant. You go from just being a coder to being a true software craftsperson.
So, I'm going to leave you with a challenge. The very next time you get a piece of code to run, just stop for a moment. Ask yourself, what's its big O? And then ask, is there a different tool, a different data structure for my toolbox that could make this even better? That question, right there, is the first step to really using your new superpower.